In early January, NASA's retired Earth radiation budget satellite is expected to re-enter Earth's atmosphere after almost 4 decades in space. For 21 of those years, the Earth radiation budget satellite actively investigated how the Earth absorbed and radiated energy from the Sun, and made measurements of stratospheric ozone, water vapor, nitrogen dioxide, and aerosols. As of Thursday, January 5, the Department of Defense predicted that the 5,400-pound satellite will re-enter the atmosphere at approximately 6:40 p.m. Eastern Standard Time on Sunday, January 8, with an uncertainty of plus or 17 hours. NASA and the Defense Department will continue to monitor the re-entry and update the predictions. NASA expects most of the satellite to burn up as it travels through the atmosphere, but some components are expected to survive the re-entry. The risk of harm coming to anyone on Earth is very low, approximately 1 in 9,400. Launched from the Space Shuttle Challenger on October 5, 1984, the Earth Radiation Budget Satellite Spacecraft was part of NASA's 3-satellite Earth Radiation Budget Experiment mission. It carried 3 instruments, 2 to measure the Earth's radiative energy budget, and 1 to measure stratospheric constituents, including ozone. The energy budget, the balance between the amount of energy from the Sun that Earth absorbs or radiates, is an important indicator of climate health, and understanding it can also help reveal weather patterns. Ozone concentrations in the stratosphere play an important role in protecting life on Earth from damaging ultraviolet radiation. Earth Radiation Budget Satellite far exceeded its expected 2-year service life, operating until its retirement in 2005. Its observations helped researchers measure the effects of human activities on Earth's radiation balance. NASA has continued to build on the success of the Earth Radiation Budget Experiment mission with projects including the Current Clouds and the Earth's Radiant Energy System suite of satellite instruments. The Stratospheric Aerosol and Gas Experiment 2 on the Earth Radiation Budget Satellite made stratospheric measurements. Stratospheric Aerosol and Gas Experiment 2 collected important data that confirmed the ozone layer was declining on a global scale. That data helped shape the International Montreal Protocol Agreement, resulting in a dramatic decrease around the globe in the use of ozone-destroying chlorofluorocarbons. On Jan 7, 2023, Stratospheric Aerosol and Gas Experiment 3 on the International Space Station collects data on the health of the ozone layer. Solar flares are powerful bursts of energy. Flares and solar eruptions can impact radio communications, electric power grids, navigation signals, and pose risks to spacecraft and astronauts. The Sun emitted a strong solar flare, peaking at 7:57 p.m. Eastern Daylight Time on January 5, 2023. NASA's Solar Dynamics Observatory captured this image of a solar flare, as seen in the bright flash on the left picture, on January 5, 2023. The image shows a subset of extreme ultraviolet light that highlights the extremely hot material in flares and which is colorized in AIA 171 orange. Inside the multi-payload processing facility at NASA's Kennedy Space Center in Florida, engineers and technicians conduct inspections of the heat shield on the Orion spacecraft for the Artemis 1 mission. Orion returned to Kennedy on December 30, 2022, after splashing down in the Pacific Ocean on December 11, following a 1.4 million-mile mission beyond the Moon and back. In this photo, technicians underneath the crew module closely examined the heat shield, which endured temperatures near 5,000 degrees Fahrenheit during re-entry through Earth's atmosphere. The heat shield will be removed from the spacecraft and taken to another facility for further detailed inspections. Teams also are inspecting the windows of the capsule along with the thermal protection on the back shell panels that cover the spacecraft to protect it from the harsh conditions both in space and during the high-speed, high-heat re-entry. On top of the capsule is the deflated crew module uprighting system, which is a group of 5 airbags that position the capsule right side up after splashdown and were deflated prior to transport back to Kennedy. While still in the transfer aisle of the facility, engineers are in the process of removing external avionics boxes. Technicians will take air samples within the capsule ahead of repositioning it into a service stand that will allow access to the interior. Upon opening the hatch, technicians will remove the internal avionics boxes and payloads. After conducting detailed inspections and testing, the avionics boxes will be reused for the Artemis 2 mission. Deservicing will continue in the coming months with the removal of the hazardous commodities that remain on board. Once complete, the spacecraft will journey to NASA Glenn's Neil A. Armstrong Test Facility for abort-level acoustic vibration and other environmental testing. Experts will discuss new research from NASA missions at the 241st meeting of the American Astronomical Society, on topics ranging from the universe's early galaxies to planets outside our solar system. The meeting will take place January 8 to 12 at the Seattle Convention Center in Seattle. Scientists and agency leaders will present the latest developments in astrophysics during various press conferences, scientific sessions, and town halls. Press conferences, highlighting results enabled by NASA missions such as the James Webb Space Telescope, Hubble Space Telescope, Chandra X-ray Observatory, and Transiting Exoplanet Survey Satellite. In addition to press conferences, NASA highlights for registered attendees include NASA Town Hall, Monday, January 9, 12:45 p.m. Pacific Standard Time. James Webb Space Telescope Town Hall, Monday, January 9, 6:30 p.m. Pacific Standard Time. NASA's Transform to Open Science, TOPS, Initiative Town Hall, Tuesday, January 10, 12:45 p.m. Pacific Standard Time. Nancy Grace Roman Space Telescope Town Hall, Tuesday, January 10, 6:30 p.m. Pacific Standard Time. The Heliophysics Big Year in 2023 and 2024 Town Hall, Wednesday, January 11, 12:45 p.m. Pacific Standard Time. Plenary and award lectures by NASA scientists discussing the Webb mission, the future of exoplanet and galaxy research, and the Neutron Star Interior Composition Explorer (NICER) mission. Two cameras aboard the Surface Water and Ocean Topography satellite captured the large mast and antenna panels of the spacecraft's main science instrument, deploying over 4 days, a process that was completed on December 22, 2022. The masts, which unfold from opposite sides of the spacecraft, can be seen extending out from the spacecraft and locking in place, but the cameras stop short of capturing the antennas at the ends of the masts being fully deployed. But before it can do that, the satellite would need to unfold its large mast and antenna panels after successfully deploying the solar panel arrays that power the spacecraft. The mission monitors and controls the satellite using telemetry data, but it also equipped spacecraft with 4 customized commercial cameras to record the action. The antennas successfully deployed over 4 days, a process that was completed on December 22. The 2 cameras focused on the Ka-band radar interferometer antennas captured the mast extending out from the spacecraft and locking in place, but stopped short of capturing the antennas being fully deployed. 33 feet apart, at either end of the mast, the 2 antennas belonged to the groundbreaking Ka-band radar interferometer instrument. Designed to capture precise measurements of the height of water in Earth's freshwater bodies and the ocean, Ka-band radar interferometer will see eddies, currents, and other ocean features less than 20 kilometers across. It will also collect data on lakes and reservoirs larger than 62,500 square meters and rivers wider than 100 meters across. Ka-band radar interferometer will do this by bouncing radar pulses off the surface of water on Earth and receiving the signals with both of those antennas, collecting data along a swath that's 30 miles wide on either side of the satellite. The data surface water and ocean topography provides will help researchers and decision-makers address some of the most pressing climate questions of our time and help communities prepare for a warming world.